Hi, my name is Sher and I'm a math and science tutor. Today, I'll be showing some more students as well as providing some updates on some of the students featured in the previous student video. All of these students have been working with me for at least a year and have all come very far in their own ways. If you like watching these sort of videos, make sure to leave a like and subscribe so you get notified on future videos. Let's get on to it. Let's look at my first student, Noah. Noah is currently in the 7th grade. Before working with me, he had a D in 6th grade math and wasn't confident in himself. Noah wasn't understanding the teacher's explanations and methodologies. With Noah, I sometimes have to use different methods compared to what is being taught to him in school. Here, you can see Noah is working on conversion problems. The audio quality of this clip's a little bad, so please bear with it. 384 ounces in 1 year. I'm going to convert it to pounds per month. Alright, remember, 1 pound is 16 ounces. If we want ounces to pounds, where do we put the 1 pound and where do we put the 16 ounces? So in school, Noah's teachers are using the fraction method, but here I'm using a slightly different method called the railway track.
We put the 16 ounces on the bottom and the pounds on the top.
Very good. And we cancel out what units?
The ounces.
Very good. We still need to do years to months. Okay, tell me what is the conversion?
12 months in the year, so the 12 months would be on the bottom, and the year would be on the top.
Very good. Yeah, that's it. And then can you tell me we need to cancel out what unit?
Cancel out the years.
Very good. Now, Noah understands this method much better than the standard one used in his school. He knows to put the same units on opposite sides of the track. How can you multiply? What will we have?
384 over.
And the denominator would be?
192.
Very good. And then this would simplify to?
2.
That's it. That's our answer. You did a really good job. With Noah, I just have to work around using different methods until I find the one he understands the best. As a result, Noah has improved to a high B student and he's much more confident with solving problems now. Next, you'll be meeting Jessica. Jess is currently in the 4th grade and very advanced for her level. Her mother wanted her to start early on algebra back when she was in the 3rd grade. When I first met Jess, she had never worked on any algebra before. We started with learning how to combine like terms by using analogies such as adding bunnies and snakes, Jess's favorite animals, to using number lines to add and subtract negative numbers. Here she is 1 year later. Jess has come a long way from adding bunnies and snakes. She's working on exponents now, a concept 3 grades ahead of her class. Question 13, so it's just the same thing over again. Can you tell me when we multiply these two we would get?
We would get, I got 1 over y to the power of 3.
Yeah, good job. And then what about this one, 14?
I got 1 over c to the power of 2.
Very good. You can see here she's applying what she already knows about positive and negative numbers and placing her answers in the denominator when the exponent is negative. And what about number 15 here?
1 over m to the power of 16.
Very good. What about 16?
1 over w to the power of 5. W to the power of 5.
Very good, because it's positive. And what about number 7? So here, Jess slips up a little, but she immediately notices her mistakes and fixes it without me having to prompt her at all. 17 here?
I got 1 over r to the power of 16.
Very good. And number 18?
1 over t to the power of 4.
There we go. Some people may think that algebra is too difficult a concept for young students, but as long as you shape your teaching methods to fit the age of the student, any student of any grade can learn concepts beyond their grade level. Jessica can now solve algebraic equations and simplify expressions all by herself. Now for some updates. If you've watched my previous video with my student, you'll remember Brandon as the hard-working student who went from a D to an A in geometry. Brandon is doing really well and has kept the momentum going with an A currently in Algebra 2. He's also working on chemistry with me and is a B student. Here's a video of Brandon and I working on his study guide for his Algebra 2 finals. So you'll notice Brandon and I are practicing rationalizing radicals here. Yeah, 16, so also very similar. Can you also do the prime factorization for 8?
Yeah. So it's just 2.
Yeah, it's just 2.
2 and 4.
Which can be divided by?
2 to get 2.
Very good, which can be divided by?
2.
2.
To get 1.
There we go. Alright, so we can put negative 2 to the power of?
Negative 2 to the third.
The third, there we go. So the whole point of using the prime factorization was to convert that 8 into 2 to the exponent of something. And then we just copy all the algebra now. Alright, so let's look at the negative sign first. There's a negative sign in the cube root. That means when we cube root the negative sign, will we get a negative answer or a positive answer?
If there's a cube root?
The negative is inside the cube root.
Yes, that means it's going to be a negative answer.
Yes, it's going to be a negative answer. What about the 2? Can we take out the 2?
Yeah. There's nothing.
There's nothing left. What about the x?
Yeah.
Yeah, we can
Nothing
take out
left.
the x. No x left. All right. And then what about y's?
Yeah, you'll take out the y and then it'll be 2 left over.
Brandon knows that we can only take out terms with an exponent greater or equal to 3, and he even knows to leave behind 2 y's in the cube root. Very good. And what about the z's?
Yeah. You'll have 5 z's left, or
Can we take out more than 3?
no.
As long as we take out a multiple of 3, it's okay. So
So you can take out 6.
Yeah, we can take out 6. So if we take out 6, what is left? It would just be
1 left.
1 left. And what about outside? Since we took out 6, it would be z to the power of?
Just 1.
Almost, because so earlier z, x, and y you took out 3, right? But this we're taking out 6, and 6 is actually 3 types.
2.
So although Brandon made a mistake about z, after a little nudge in the right direction, he was able to understand the concept better and get the right answer. So instead, we should do z to the power of
2.
2. Does that make sense to you?
Yeah.
You may also remember Mark from that video too. He was the student tackling the Oxford MAT question. Mark recently took the PSAT 8-9 as a 9th grader and got a 1330 out of 1440. He got a 710 out of 720 in the math section and a 620 out of 720 in the reading and grammar portion. He's also in the 99th percentile for both sections. Mark has also begun working on chemistry and physics classes with me. Here's a video of Mark and I working on empirical formulas in chemistry. So always do the same thing. If you know it's got lead, carbon, hydrogen, set up the table. Pb, carbon, H. Does it make sense so far?
Yeah.
So mass, molecular weight, we'll just put in all the different numbers. 38.4, 17.83, and 3.74. Can you tell me what is the molecular weight for all of these? Number 82.
So that'd be 207.
207, very good. The mass of carbon.
Mass of carbon, that is 12.
12, very good. Mass of hydrogen is?
Mass of hydrogen, 1.
There we go. All right, can you find the ratio now?
So you do 38.43 divided by 2. So 0.1 18565.
Very good. And for carbon?
1.4858.
Very good. And hydrogen?
So you just get 3.74.
There we go. Let's put it all in ratio form. Can you change this first number into 1? What will we have now?
So you'd have 0.18465. So 8.
Yep, so 1 is to 8 is to
20.1.
20.1, which is small enough. So what's our empirical formula?
So the empirical formula would be PB, C8, and then H20.
There we go. And there you have it. Here are more of my students. Do leave a like and subscribe if you enjoyed watching the video. Thanks for watching.